Welcome to W5U1 Direct Instruction Part 1. In the last unit, we understood the nature and use of scaffolding in instruction. The outcome of this unit is understand the principles of direct instruction. Direct instruction is the format with which most of the faculty are quite familiar, in the sense that it is the face-to-face instruction in traditional classroom setting. This continues to be the most commonly used approach to instruction, particularly in formal programs. Formal programs are characterized by things like fixed times, tight schedules, vast syllabus to be completed in the given time. So many constraints are there. The content to be delivered in fixed time is generally quite vast in formal programs. If it is a semester, 14 weeks may be available for instruction. Similarly, in a trimester, it is a fixed time. The instruction schedules are fairly rigid. When the classes have to be held, when the internal tests have to be conducted, all these are fairly rigid. And under these conditions, direct instruction is perceived by many to be the most efficient. That is, given all these constraints in terms of time, schedules, etc., in terms of the resources also, direct instruction is perceived to be the most efficient. Perhaps not most engaging or most effective, but certainly most efficient. One common concern with direct instruction is that students admitted to engineering programs are relatively homogeneous, that is true. Still, significant differences do exist in the cognitive abilities of the students, in the level of their entry-level competencies, and in their motivations. While the cohort is relatively homogeneous, there are significant differences, and it may be very difficult to accommodate these differences in direct instruction. There is no personalized approach in direct instruction. We need special approaches to address slow learners as well as fast learners. Several models for direct instruction have been proposed in the literature. It is face-to-face traditional classroom setting, but within that, the specific model for direct instruction can be different. So several such models have been proposed. One general attribute of these models is that essential content is taught to the students via an active presentation by the teacher. Another common feature is that the teacher is in control of the entire process of instruction, though they do take the preferences of students into account. Teacher determines what is the sequence in which the content has to go, when should the class start, and what should be the depth of the content. All these decisions are made by the teacher. So teacher is in control of the entire process of instruction. We present a model of direct instruction that is based on Merrill's first principles, which you have discussed earlier. That model we present in this unit, and another model of direct instruction called transactional model in the next unit. Let us just recall Merrill's first principles of learning or first principles of instruction. We saw that in the earlier unit, the 5 first principles of instruction as stated by Merrill are task-centered principle, activation principle, demonstration principle, application principle, and integration principle. A direct instruction model based on Merrill's first principles Again, let us recall that Merrill's principles are not in and of themselves a model or method of instruction. We can implement different models incorporating the Merrill's principles. So, a direct instruction model that implements all these 5 first principles is presented now. In this model, instruction consists of a sequence of instruction units. An instruction unit is associated with one specific course outcome, or in case the course outcome is expanded further into competencies, the instruction unit is associated with one specific competency. That is how the instruction unit is organized. The instruction unit implements all the 5 first principles of instruction. So that is a model. A sequence of instruction units, one instruction unit associated with one outcome or competency, and that single instruction unit must implement all the 5 principles of Merrill. So the instruction based on Merrill's principles, the unit, you can see, is structured around course outcome or competency. That is the task-centered principle of Merrill. Then we have basically 4 phases corresponding to the Merrill's principles: attention and activation in the first quadrant, then demonstration next quadrant, application engagement the third quadrant, and finally integration, that is the fourth quadrant. The course outcome or competency, all the 4 phases of instruction occur in the context of one specific CO or competency. Learning is focused around this CO or competency, and the tasks students are expected to solve reflect this principle. This feature is based on Merrill's task-centered principle. Then we have the phase of attention and activation, and this phase is primarily based on the activation principle of Merrill. However, in the model that we are presenting now, another learning principle is included in this phase. Apart from activation principle of Merrill, we also include the principle of attention, which is based on Gagne's theory discussed in an earlier unit, Gagne's theory of 9 events of instruction. Attention of students can be gained through motivational stories, examples, case studies, and simulations. We have discussed this in much greater detail in the earlier unit when we were discussing Gagne's theory. This attention activity allows students to understand the relevance of the CO or competency. Where does it fit into their scheme of study? How it is relevant to their professional growth? All these are captured in this attention phase. Then activation, which is from Merrill. Students need to be able to link their new learning to something they already know. An appropriate mental model is required to be recalled. So the prior learning and the required mental model are, within quotes, activated. Which are the instructional components that we can use? There are several. We have discussed several instructional components in the earlier units. So, explaining why, motivational stories, a small class discussion, a quiz, quickly trying to recall the earlier knowledge, competencies gained by the students, a concept map showing what has been learned earlier by the students and linking it up with what they are going to learn now. Advanced graphic organizer. There are several components. Instructor is free to choose a component which best suits the given context. Then next we have demonstration. This is the demonstration principle of Merrill. We are calling the demonstration phase of our instruction unit, which is based on the demonstration principle of Merrill as the next phase. Here, the presentation of new information, that is Merrill's information concept, happens. One or more worked examples of a problem based on the CO competency, that is what the instructor does in the classroom. This shows how the presented information is applied to specific situations, which is the portrayal concept of Merrill. So this demonstration should be consistent with the nature of the CO. The specific outcome, learning outcome that the instructor is planning to have the students achieve, that specific outcome and the demonstration that the instructor is engaging in must be consistent. So learners should be guided to relate general information to specific instances. The instructional components that can be used: interactive lectures, multimedia presentations, simulations, example problems, field demonstrations, experimental demonstrations. All these are possible and several other components are possible. In fact, a wide choice of instructional components exists today for the instructor for using during this demonstration phase, particularly with the availability of the technologies based on AI. The next phase is application engagement. This is applied principle of Merrill. Learners should engage with, in other words, apply the newly acquired knowledge and demonstrate skills to solve problems consistent with the competency. So learners should engage with the new information and skills with minimum time gap after the demonstration. This is considered by many instruction theories to be extremely important. That is, once the student acquires new knowledge, she must immediately engage with that new knowledge. She must use it to solve a given problem. She must apply that knowledge, and this must happen as quickly as possible after the learner has acquired the new knowledge. This will make the learning deeper and more meaningful for the learner. So learners should engage with the new information and skills with minimum time gap after the demonstration. The instruction unit must be planned to make this happen. Learners should receive either intrinsic or corrective feedback to ensure correctness and adequacy of their newly constructed mental model for solving the problem. This again is considered as very important by all the theories. They always should receive corrective feedback, and this again must be provided to the students in a constructive way as quickly as possible after the students try to apply their new knowledge. Scaffolding discussed in the previous unit, like coaching, providing hints, they all can certainly improve learning. Scaffolding, as we emphasized in that unit also, should be gradually withdrawn. So what are the instruction components which can be used? Note making, summarization, individual problem solving, practice, group problem solving, report writing, making presentations, group discussions. Again, a wide array of components, instructional components are available to the instructor. Then we have the phase of integration, which essentially is the integration principle of Merrill. Learners should reflect, discuss with peers, relate them to their existing mental model. The newly acquired knowledge must be integrated into the framework which earlier had only the prior acquired knowledge. That prior knowledge is now integrated with the new knowledge, and this becomes the new mental model of the student. This is extremely important. The student must reflect on what he or she has learned in this instructional unit. So instructional components can be, we can have class discussions, we can have group discussions, we can have a quiz, quick one, a quiz. It doesn't take too much time, but a quick one, and you can use tools like clickers. And the summarization, the students can be asked to make a small note summarizing what they have learned in this unit. There are so many units, so many components that are available to the instructor. So, what is the structure of such an instructional unit? We have first CO, competency statement. We start with that, and this is made known to the students. They know upfront what is the competency that they are expected to demonstrate at the end of the instructional unit. This is also the principle of outcome-based education, which we have discussed in a related NPTEL course. Then we have the phase of attention activation. Then we have a demonstration followed by an application. But this may not happen in one go, depending upon the competency or the course outcome and its complexity levels. We may need to go through multiple rounds of demonstration application or multiple cycles of demonstration application. So we are showing it as demonstration 1, application 1, demonstration 2, application 2, demonstration 3, application 3, like this. Finally, demonstration K, application K. That is K rounds of demonstration application. Of course, it could be that K is 1 in the sense that in one single go of demonstration and application, the instructor has achieved what she wanted to achieve. Then that's also fine. But if you need more rounds, the instructor goes through as many rounds as required. But notice that the attention activation phase occurs only once. Then we have the cycle of demonstration application phases, repeating. Then finally we have an integration phase. This also occurs only once at the very end of the cycle of demonstration applications. So we have an attention activation phase, then we have one or more iterations of demonstration application phases, then one final integration phase. This is an example, just a sample unit. In fact, it is presented by the participants in one of the workshops that we held. The competency, it is related to one particular outcome, CO5, and that has been expanded further, and one particular competency C4 is what is the focus of this instructional unit, and that competency is design precision rectifiers and DC voltage regulators, and the allocated time is 2 classroom hours. There is no lab time which has been allocated. So the CO5 itself, so that we know the context in which this competency is being incorporated, CO5 itself is design circuits that perform analog linear signal processing functions, including amplification, summing, differentiation and integration, and non-linear signal processing functions, including log and anti-log amplification, current sensing, rectification and DC voltage regulation using passive and active devices. This is the overall course outcome. Within that, a specific competency that is the focus of this instruction unit is as given above: design, precision rectifiers and DC voltage regulators. So the classroom session, first session, the time allocated is also shown. It looks like too much detail, but the instructor has to do it only once. And of course, if necessary, they can certainly update it. But once you do this and once you demonstrate the efficacy of this mechanism, the instructor is quite comfortable without referring to such a detailed breakup. But the first time, if you are offering a particular course, such a detailed breakup gives you an extremely good idea of how the time should be spent in the classroom. So, while this looks somewhat detailed, it is worth the instructor's effort to pay attention to such small details, at least when they are delivering the course for the first time. So, relevance, spend about 3 minutes. Precision rectifiers are necessary for low voltage AC to DC conversion, and DC voltage regulators are required in creating a stable DC voltage source for electronic circuits. And if you want, you can give some applications where it is being used, and you could simply use a PPT. Then activation, about 10 minutes. So the instructor could present a macro model of a diode, characteristics of op amps, Zener diode and current booster. This again can be based on a PPT. In addition, the instructor can pose a quiz and see how the students are responding, and if the instructor feels it is relevant, she can discuss the responses to the quiz in the classroom quickly, trying to eliminate any misconceptions that the students may have, and trying to help the students recall their prior knowledge. Then we have demonstration 1, application 1, 30 minutes and 15 minutes. Explain the behavior of half wave and full wave rectifiers and precision rectifiers and simulate their behavior, perhaps using some kind of a tool which is available. So this can be again simply a demonstration of the principles on a board, or it could be a PPT, or it could be actually a simulation, and that simulation could be demonstrated in the classroom also. There is no problem. And in the application, simulate a precision half wave circuit and demonstrate its precision over the input voltage range of 10 millivolts to 5 volts. While we are explaining the behavior, it is general in nature. But now, during the application, one specific instance, one specific problem is solved by the students. So we specify, like for example, the input voltage range and other issues, okay, precision, everything, and according to that, the students have to apply it. Then in this case, the instructor has decided to have one more round of demonstration application for 35 minutes and 15 minutes. Explain the characteristics and parameters of voltage regulators, operation and design of linear voltage regulator and the low dropout regulator. That is just on a board. That is how the instructor has decided. Then during the application time, the students design a linear voltage regulator. So that is the second round. With that, the cycle of demonstration application is over for this instruction unit. So we have finally one single phase, which is integration phase. That is for 10 minutes. The instructor discusses the role of feedback around an op amp in achieving two important signal processing applications, including precision rectification and voltage regulation. And the instructor can engage the students in discussing these ideas so that the students are able to integrate this knowledge with their prior knowledge. So that is the model of direct instruction based on the Merrill's principles. In the next unit, we will look at another model of direct instruction, and we call that as transactional model. This is also based on direct instruction, And this also makes use of Merrill's principles, but there are certain differences. So we call that as transactional model, and in the next unit we will discuss the transactional model of direct instruction. Thank you. We will meet again in the next unit. Thank you.